Okay, well, now, if you will, let's move over to page 247 and let's look at example 2, where we're going to be asked to find the products of pure imaginary numbers. Now, anytime we see the term product in math, we know we're talking about multiplication. And so what we're going to be asked to do, we're going to take a pure imaginary number, which is in the form of bi. We have this imaginary number I that has a coefficient with it that's a real number. So looking here at guided practice 2a, we'll start with this one. We've got 3i times 4i. Well, in some respects, I'm going to treat this just like I would anything with a variable in it. And I'm just going to multiply those two together. And so that's going to give me 12i squared. But we know from the previous lesson that I squared equals -1. So now I've got 12, in reality, 12 times -1. And so the product of 3i and 4i is -12. All right, that's not too bad. Let's look at the second one, 2b. Now this one, we have the square root of -20 times the square root of -12. And I'm going to break down each one of these radicals. And so the first thing I see, I'm going to start here with -20. Let's put this in a different color maybe. Well, I can define -20 as the square root of -1 times, and I'm trying to find now, I got rid of the negative. I got it set by itself. And of course, the square root of -1 is going to equal I. Let's see, 20. I'm thinking about, is there a perfect square inside of 20? Well, 4 times 5 is 20, and 4 is a perfect square. So I've got the square root of 4 times the square root of 5. All right. Now let's put our thinking into -12. Well, I got a negative there, so I got the square root of -1, which of course is going to be I. And is there a perfect square inside of 12? Well, 4 times 3 is 12. So again, I've got the square root of 4 times the square root of 3. All right, so if the square root of -1 is I, and the square root of 4 is 2, well, now I've got 2i times the square root of 5. And here on the right-hand side, again, I've got square root of -1, which is I, and the square root of 4, which is 2. And so I've got 2i times the square root of 3. All right, well, now we're getting close. All right, so now we're going to multiply these two together. So I got 2i to the square root of 5 times 2i to the square root of 3. Well, multiplying this together, that's first going to give me 4i squared times the square root of 15. Square root of 5 times the square root of 3. But what is I squared? I squared is -1. So now I've got 4 times I squared, which is -1, and that's going to leave me with -4 times the square root of 15. And there we have found the product of pure imaginary numbers. Now, one more. And here we're asked to find the value of I raised to the power of 31. Now, remember, we got this pattern of 4 that we see in this imaginary numbers when we're raising those exponents. And I'm going to take the 31 and I am going to divide 31 by 4, excuse me. 31 divided by 4. And I'm going to focus on the remainder. So 4 goes into 31 7 times, and that would leave me with a remainder a remainder of 3. 4 times 7 is 28. 31 minus 28 is 3. And so I raised to the power of 31 is going to equal, so I raised to the power of 31 is actually going to equal I raised to the power of 3. Now, what was the power of 3 equal to? Well, the power of 3, we're going to say I squared, I to the raised to the power of 31 is equal to negative I. All right, there we go. There's probably practice in order. What you think?